On the 18th of June, something remarkable happened. A company that most people haven't heard of, yet alone are able to pronounce the name of correctly, soared to the point where it overtook Apple and Microsoft to become the most valuable company in the world. This is, of course, Nvidia, and in the last 5 years, its market cap has risen roughly 3,000% to a high of over $3.4 trillion, and its CEO has gone from being a relative unknown to receiving rock star treatment. In this video, I want to break down the business and explore whether I think this meteoric rise can continue. Or in other words, try to understand how big is Nvidia's moat. Firstly, I'd like to quickly set the stage by running through Nvidia's founding story and explaining how it got to the position it is in today. The story begins 31 years ago in Silicon Valley inside a Denny's roadside diner, where three men gathered to discuss a future venture. One of these men was Jensen Huang, who had previously worked as a teenager at the same restaurant chain, doing jobs including being a dishwasher, busboy, and cleaning bathrooms, roles which he said enforced his view that no task is beneath him. At the time, he was working as the director of CoreWeave at LSI Logic, a company that designed and sold semiconductors, having earned a master's degree from Stanford University a year prior in electrical engineering, and previously worked as a microprocessor at AMD. He brought with him a lot of expertise in the world of chips. As did the two other Nvidia co-founders, Chris Milikowski, who had worked at HP before, working as an engineer at Sun Microsystems, as well as Curtis Preem, who while at IBM worked on one of the first graphics processors for the PC before joining Sun as a staff engineer. Jensen likes to say that Curtis and Chris told him they were planning to leave Sun and they wanted him to join them in starting a business, although they weren't sure what that business would be. Hence, after agreeing to partner together, they needed to quickly decide on what company they wanted to start, seeing a significant market opportunity in providing specialized hardware to handle the increasingly complex and visually demanding rendering that was needed in the burgeoning video game industry. They set their sights on creating 3D graphics cards for gamers. 3 decades later, Jensen admitted that had he known the sheer amount of pain and suffering that would ensue in running Nvidia, he would have turned down Chris and Curtis's offer at the now famous Denny's booth, which is adorned by a silver plaque celebrating the company's multi-trillion-dollar success. However, the hardship came early. Nvidia released their first product in 1995, the NV1 graphics chip. It used quadratic texture mapping for 3D graphics rendering, which was an innovative technique, albeit one that quickly became virtually obsolete. As that same year, Microsoft unveiled DirectX for Windows gaming that used triangle-based rendering, not the quadratic surfaces used by the NV1. The huge investments the company had made had largely gone to waste, and the next year, Nvidia's management made the decision to lay off half of all the employees. At the time, the Japanese video game company Sega had agreed a contract with Nvidia for their Dreamcast games console. However, they decided to move forward with another graphics chip vendor for the console. It now looked increasingly like Nvidia would soon be going out of business. Which, by the way, would not be unique at all. Of the approximately 70 companies focused on graphics acceleration for video games in the late 90s, only 2 survived, AMD and Nvidia. Despite cancelling the contract, Sega's president at the time, Shoichiro Irimajiri, believed in Nvidia, and so he convinced Sega's management to make a strategic $5 million investment in the company. Jensen later said that Irimajiri's understanding and generosity gave Nvidia 6 months to live. It was then all hands on deck. They fought tooth and nail to release a graphics accelerator optimized for processing triangle primitives, which they miraculously were able to pull off. The Riva 128 was sold millions of times, being released with a mere 1 month of payroll left in the bank. This precarious situation lay birth to a phrase that Jensen likes to repeat to employees, even now, that Nvidia is only 30 days from going out of business. In spite of the fact that the business now has $35 billion in cash and short-term investments on their balance sheet. It's a tongue-in-cheek way to fend off complacency in a company which is now in a remarkably different situation. In 1999, Nvidia became a publicly listed stock, and they released the GeForce 256, the first graphics chip that they marketed as a GPU, Over the next decade, the business continued to progress in the video game industry, technologically and financially, including receiving a lucrative Xbox contract. In 2006, Cuda, standing for Compute Unified Device Architecture, was launched by Nvidia. As I'll discuss later on in this video, this software ecosystem, which is used by developers to harness the power of Nvidia's GPUs, is in many ways the linchpin of the company's moat. It took some time, however, for the importance of this software to be truly realized. In the meantime, GPUs were beginning to be adopted by industries outside of the video game market. 6 years after Cuda's release, two Nvidia GeForce GTX 580s were utilized by Alex Krzyzewski, Ilya Sutskever, and Jeff Hinton to empower the groundbreaking AlexNet convolutional neural network. Using Cuda, the three researchers were able to optimize key operations such as convolutions, pooling, and activation functions, as well as leverage GPU acceleration, master memory management, and GPU virtualization, and do so much more. For more about AlexNet, you can see the video I made on the topic last December, but the point to remember is that leveraging NVIDIA GPUs, the three researchers were able to make more progress than had ever been possible in using artificial intelligence for image classification tasks, and as a result, they won the ImageNet competition by a substantial margin. NVIDIA was beginning to transition from being a company that rendered the most demanding video game graphics to being an accelerated computing conglomerate, with its chips being used by AI academics as well as crypto miners, who took advantage of the innate ability of the chips to excel at matrix multiplication and applied this strength in parallel processing to complete multiple calculations at once, so that the crypto miner who reached the solution first, usually the one with the most or the best GPUs, was rewarded in cryptocurrency. Their GPUs were now far more performant than the most advanced CPUs developed by Intel and other chip vendors for high-performance computing tasks. Consequently, their chips became in high demand by companies working on the most computationally intensive tasks, including a young startup by the name of OpenAI. In 2016, Jensen personally delivered NVIDIA's very first supercomputer, the DGX-1, with an 8 GPU cluster based on the Pascal microarchitecture to the OpenAI founding team that included Elon Musk, Sam Altman, and Ilya. A year later, the Attention is All You Need paper was published, shedding light on the transformer architecture, which enabled the scaling laws that were necessary for some of the later breakthroughs to come. As AI developed, it wasn't enough to have chips in a workstation or computer. It became necessary for the chips to be racked together within servers inside vast data centers. While many customers would buy chips from NVIDIA's long list of partners who had their own sales teams, an increasing number of developers were accessing them from one of the big four cloud companies, AWS, Azure, GCP, and Oracle Cloud Infrastructure. This was all made easier by NVIDIA's acquisition of Mellanox Technologies, a networking company for data centers, a deal that closed in 2020 for $6.9 billion. Mellanox and InfiniBand networking provided the high-performance backbone which boosted the further scaling of AI workloads, reducing latency between GPUs and enabling efficient parallel processing of data. It allowed the hyperscalers to train massive AI models faster and more cost-effectively, maintaining NVIDIA's position as the go-to solution for large-scale AI infrastructure, whereas many other networking solutions outside of NVIDIA's would fall short in the face of these massive clusters due to bandwidth limitations and higher latency. Still though, in spite of all of this, when you look at NVIDIA's annual reports, gaming continued to take the largest share of the company's revenue, up until the fiscal year 22, which ended January the 30th, 2022, and then an explosion happened. Data center growth took off like a rocket ship. Companies were using the increasingly scarce GPUs to power the autonomous systems of self-driving cars through NVIDIA's Drive platform, for medical imaging via NVIDIA's open source Moat toolkit, and most significantly, at the tail end of 2022, the world came to see that Nvidia's chips had been used for the training and inference of OpenAI's ChatGPT 3.5, a large language model that took the world by storm, and launched an arms race that's not slowed down since, with Larry Page, the founder of Alphabet, saying that he would rather go bankrupt than lose the AI race. Elon Musk building a cluster of 100,000 H100s to support the efforts of his AI startup XAI, and Meta's Mark Zuckerberg spending over $30 billion purchasing GPUs for his company to get ahead in the race, a sum that is equivalent in inflation-adjusted terms to what the US government spent on the Manhattan Project. Now with Blackwell, Nvidia's newest microarchitecture, which by the way yields performance 4 times that of its predecessor Hopper, and has demand forecasts that far exceed supply projections, and the stock running up as it has in data center revenue, which was $26.3 billion in the latest quarter, now dwarfing all other business segments, including gaming. I'm interested in assessing the question of Nvidia's moat. And yes, I know I went into a lot of detail setting the stage, but for a company that has quickly come to dominate so much of the technological and financial discourse, I think a proper introduction is warranted. The way I want to do this is by splitting this discussion into 2 parts. The first part will be focused on the software side of the business, and the second part will center on Nvidia's relationship with big tech. I mentioned Cuda before. It's important to understand that estimates say there are about 4 to 5 million developers who use Cuda. That's an extraordinary number, given that there are far fewer kernel engineers than, say, your typical front-end or back-end developers. In fact, when other GPU companies try to get developers to pick up software that optimizes their proprietary AI accelerators for the data center, they struggle. Because due to Nvidia's first mover advantage and the fact that it's added such a comprehensive suite of libraries, tools, and resources around Cuda, the ecosystem has become the de facto standard for GPU accelerated computing in various fields, including scientific computing, machine learning, and computer vision. This situation creates a significant challenge for companies using products from Nvidia's competitors, as they face greater difficulty in recruiting kernel developers experienced with alternative GPU architectures and their corresponding programming models. For those who are unfamiliar with the competitive landscape around Nvidia, I'll give a primer on this before returning to Cuda. So, traditionally, the 2 companies that have been thought of as Nvidia's main competitors are AMD and Intel. They compete inside the hardware of phones and computers, in gaming, and in AI and machine learning, as well as a number of other industries. But taking AI and machine learning as an example, as it's really the most important area for this comparison, GPUs significantly outperform CPUs due to their architecture optimized for parallel processing, which is particularly well suited for AI workloads. Intel does about 30 billion in sales of its CPUs, and AMD did close to 19 billion in CPU sales last year. However, as far as GPU sales go, the revenue estimates for 2024 are for Intel to do about $500 million in sales, that's in consumer and data center markets combined, and for AMD to do 4.5 billion of GPU sales, much of which will come from the MI300X chip, part of the Instinct series that's designed to compete directly with the H100. Meanwhile, Nvidia is estimated to do a massive $105 billion of GPU sales this year. These revenue estimates illustrate that right now, Nvidia has overwhelming market leadership in the competitive landscape for AI-focused GPUs. Nonetheless, Intel is working on one API, a unified programming model for CPUs, GPUs, and other accelerators, which competes with Cuda, and AMD also have an open source software platform for GPUs, Radeon Open Compute, named because of their Radeon graphics processing units. The problem is that millions of programmers have been trained on Cuda, but very few have been trained on those 2 open source systems. Oh, and in case it's not clear, Cuda can only be used for NVIDIA's GPUs. So in order for AMD and Intel to meaningfully challenge NVIDIA in the GPU market, they'll likely need to make headway in adoption for their software, which in spite of being open source, aren't optimized for cross-compatibility. This creates a significant barrier to entry for AMD and Intel, as they not only need to compete on hardware performance, but also need to convince developers to learn and adopt new programming models. The network effects of CUDA's widespread adoption makes this an uphill battle, as many organizations have invested heavily in CUDA-based infrastructure and expertise. For AMD and Intel to succeed, they may need to not only improve their hardware offerings, but also invest in robust developer education programs, create compelling tools and libraries, and potentially offer seamless migration paths from CUDA to their platforms. Additionally, they might benefit from collaborating on a unified open standard that could rival CUDA's ecosystem. Though such cooperation between competitors has its own challenges, I think this would be the best path. OpenCL, which is compatible with Intel, AMD, and in a limited fashion Nvidia, would be an option here. It allows for portable code to be written that can be optimized for specific hardware and for vendor specific optimizations and features to be added as needed. While it has wider option than one API and ROCm, there is still a big usage gap. Nevertheless, there's a final software solution that NVIDIA does not like, but which may prove to be the greatest threat to the moat posed by developer lock-in with CUDA, aside from the involvement of the Justice Department, that is. This approach is to convert CUDA code to run on non-NVIDIA hardware. One notable effort here is a project I heard Chamath Palihapitiya reference on the All In podcast that Eric Schmidt is also on board with. They're both working to build a CUDA transpiler. Furthermore, AMD invested in a company called Lamini that's working on recompiling CUDA code to AMD's ROCm platform in near real time. Whether these efforts will be successful is TBD, but now I would like to move on to the second part of this discussion, NVIDIA's relationship with big tech. When you read NVIDIA's latest 10Q, there's something very striking that becomes immediately obvious, and that is the concentration of NVIDIA's sales amongst a very small number of customers. I mentioned earlier that the data center revenue for the last quarter was $26.3 billion. Moreover, I also said that from its founding to the fiscal year 2022, gaming revenue was the largest business segment. Well, in the second quarter of fiscal 2025, gaming brought in $2.8 billion in sales, by no means a small number, but still less than what 4 individual customers spent on the data center with NVIDIA. Each of these customers, and these are almost certainly Amazon, Alphabet, and Microsoft, so the hyperscalers, as well as Meta, represented at least $3 billion of spending to NVIDIA. One of the 4 who NVIDIA refers to as customer B, this is likely Meta or Microsoft, represented over 14% of total revenue for the quarter, approximately $4.2 billion. Put together these 4 companies, and you have 46% of NVIDIA's total revenue for the quarter. And if you add customer E to the equation, who represented over 10% of total revenue for the last 2 quarters combined, it seems highly likely that more than half of NVIDIA's sales came from just 5 customers, all big tech. My guess is that customer E is either a Musk Corp, i.e. Tesla or xAI, or more likely OCI, Oracle Cloud Infrastructure. In fact, reportedly, OpenAI has turned to Oracle Cloud to provide additional compute capacity, as Azure doesn't have enough spare H100s. This is very lucrative, especially with NVIDIA's 75.1% operating margin, a level of profitability that most companies would kill for. But is it sustainable? Can this trend continue? This is a question that Wall Street analysts spend a lot of time researching and considering. I'm not a Wall Street analyst, but I would like to explain why, even though I think NVIDIA will continue to do incredibly well into the future, I believe that their margins and market share will erode over the course of, let's say, the next 5 years. With the current pace of change and innovation, even 5 years may be stretching it, but I'll try anyway. The big tech companies are lining up to order Blackwell, as I'm sure they will do for Rubin as well, the GPU platform that will follow Blackwell. Nvidia is now releasing a new product every year, but these customers that have been so crucial to their growth are also releasing their own chips. Google has been at the forefront of developing custom AI chips. Their tensor processing units, TPUs, are now in their fourth generation and are specifically designed for machine learning workloads. At a recent Goldman Sachs tech conference, Google Cloud CEO Thomas Kurian stated that 90% of AI unicorns run on GCP for training and inference, and 60% of all AI funded startups ever use their infrastructure for training or inference. Google's TPUs are not just for internal use, they're available to customers through Google Cloud, and some companies, including Apple, are using TPUs instead of Nvidia's GPUs for certain workloads. But it's not just Google. Amazon has developed AI accelerator chips, Inferentia, optimized for inference workloads, and Trainium, which, as the name suggests, is designed for training AI models. Amazon offers these chips to AWS customers, providing options for both training and deployment of AI models within their ecosystem. These chips that Amazon has been working on since about 2016 are part of AWS's strategy to provide cost-effective alternatives to NVIDIA's GPUs and reduce reliance on external providers for AI hardware. Some of the notable companies using Amazon's AI chips include Runway ML, who I recently did a video on, and who are innovating in AI-powered filmmaking, using inferential chips for their inference tasks. There's also the AI unicorn Databricks, valued at $43 billion, who utilizes EC2 TRN1 instances powered by AWS's Trainium accelerator for their AI workloads. And perhaps most significantly of all, Anthropic, one of OpenAI's most important competitors and a leader in the battle for LLM supremacy, trained their Claude 3.5 Sonnet model using both Inferentia and Trainium chips. At release, this model topped the MMLU Pro Massive Multitask Language Understanding Dataset leaderboard, though competition among top LLM providers remains fierce. AWS's CEO, Matt Garman, has said that while lots of AWS's customers are still choosing to use NVIDIA's chips, he is seeing customers save a staggering 60 to 70% on their inference bills when they move from NVIDIA to Inferentia. And while he's still happy to own thousands of NVIDIA GPUs for customers to rent out, he's very enthusiastic about the value that will be unlocked with the upcoming Trainium 2 chip. Neither Amazon's nor Google's chips run on Cuda. Amazon's chips are optimized using an SDK called Neuron, and Google's use XLA, standing for Accelerated Linear Algebra. And what I'm about to say is important when understanding the strength of Cuda's moat. Both Neuron and XLA have framework support for TensorFlow, which Google originally developed, and that is based on Python, and PyTorch, developed by Meta, and also written in Python. These two frameworks have significantly larger user bases compared to Cuda. Cuda, which is written in C and C++, uses languages that ranked 9th and 10th respectively in Stack Overflow's 2023 survey of the most popular programming languages. In contrast, Python, the language underpinning both TensorFlow and PyTorch, ranked 3rd in the same survey. This disparity in language popularity and framework adoption illustrates the evolving landscape of AI development tools and the challenges facing Cuda's dominance. It may therefore be that AWS and GCP have a much easier time getting developer adoption to their respective software ecosystems than AMD or Intel, because there's already quite high familiarity with TensorFlow and PyTorch among machine learning engineers. I'd like to talk about NVIDIA's two biggest customers, Microsoft and Meta, but before I do, I'll first speak about a constraint that all of these customers face, and this is hardware. All of the companies that want to design the most cutting-edge advanced semiconductors have to go through the Taiwan Semiconductor Manufacturing Company, because only TSMC is able to build the chips on, say, the 3nm level. And as a result, they have about 90% market share of advanced chip manufacturing, because the other fab companies like Intel and Samsung simply can't compete. Relying so much on TSMC has its issues, though, as it's just a single company with a finite production capacity, and so you're seeing supply constraints like with Blackwell. The probability of these supply constraints continuing to happen, I think, will only continue as all these trillion-dollar behemoths queue up for the Taiwanese giant to manufacture their chips. Not to mention the enormous geopolitical risk of China either doing a full invasion of Taiwan or quarantining Taiwan in a way not dissimilar to how America quarantined Cuba during the Cuban Missiles Crisis, and thus preventing the exports of chips off the mainland. If the CCP made this kind of move, then I don't think it's hard to imagine Nvidia's stock breaking records for the most market value lost in a single day, especially when you look at how little it took for the stock to fall by roughly $300 billion in one day in early September. Who knows, maybe the AI unicorn Android Technologies can play a role in helping to protect this nexus for chip manufacturing. The manufacturing process itself is incredibly complex, requiring specialized equipment from companies like ASML, whose EUV lithography machines are critical for producing cutting-edge semiconductors. ASML is the only company in the world capable of producing extreme ultraviolet lithography machines, which are essential for manufacturing the most advanced chips. So, to summarize, if anything serious were to happen to ASML or TSMC, Nvidia would basically be screwed in the short to medium term. But so, of course, with the efforts of the big tech companies trying to loosen the reliance they currently have on Jensen's company. Speaking of which, Microsoft reportedly turned to both Intel and AMD to try to reduce their dependence on Nvidia. Given that AMD does not have Cuda, they were difficult to work with. Furthermore, they had memory and overheating issues with the MI300X, whereas Microsoft viewed Intel as lacking anything substantial with regards to AI accelerators for the data center. Microsoft, recognizing the challenges in securing sufficient AI hardware, decided to develop its own application-specific integrated circuits, ASICs. This decision led to the launch of Project Athena, an internal initiative aimed at creating proprietary AI chips. To their surprise, they were able to design chips that had much better performance and efficiency than they had expected. Hence, in November of last year, they publicly announced the Maya 100 AI accelerator. Microsoft began deploying their Maya 100 chips in their data centers starting earlier on this year. These chips are used to support services like Microsoft Copilot and Azure OpenAI service, and the Maya 100 will complement existing third-party offerings from industry partners such as Nvidia's H100 and H200 Tensor Core GPUs and AMD's MI300X chips. But by introducing its own silicon, Microsoft aims to expand its product range, providing customers with more options in terms of cost and performance. And while this is clearly a more nascent effort than those of AWS or GCP, and these chips are only used for Microsoft workloads so far, they will likely be available for other companies to use. And I believe this increased competition will eventually put pressure on NVIDIA's margins. And as customers will have more options, they may need to adjust pricing to remain competitive. And if you're wondering about what Microsoft's CUDA equivalent is, the Maya SDK directly supports Triton, which is an open source Python framework developed by OpenAI specifically for GPU programming. In addition, developers can also run PyTorch models with only minor adjustments to their code. It seems that GPU programming with Python is a recurring theme amongst the hyperscalers. One thing I don't want to diminish, though, is how in many ways NVIDIA still has by far the strongest silicon. Their GPUs are also more versatile than ASICs, which are more specialized for specific tasks. And therefore, when you think about the three hyperscalers who I've just spoken about, much of their spending will still be determined by what their customers want. And if their customers still want NVIDIA GPUs, they'll continue to buy them. The Chief Investment Officer of Atreides Management, Gavin Baker, has pointed out that early on, NVIDIA found that it's not only about the GPU, but also about having a fully vertically integrated system. So they bought everything they could in-house. They bought Mellanox because they saw InfiniBand as an essential and high-margin product. The only thing NVIDIA doesn't yet have in-house is storage. But he thinks they won't have that because it's a low-margin business. And this is a point that's worth appreciating. Just as Cuda includes a myriad of different tools and libraries, there's also a very layered hardware stack for Nvidia's technology. I mean, it's not preordained that the circuitry architecture of Nvidia's GPUs is the optimum solution for matrix multiplication. A group of electrical engineering PhDs may manage to find product market fit with a new assembly process they've designed that is able to do accelerated computing in a cheaper and more performant way, assuming they also meet the capital requirements to partner with ASML and TSMC. But they may still be lacking all of the other sophisticated technologies that go with the NVIDIA chip, and for that reason, it might not be enough to be a complete solution. As a side note, had Nvidia not been blocked by regulators in trying to acquire the UK semiconductor design company ARM for $40 billion 2 years ago, by the way, I checked the market cap, and it's now about $155 billion, by the way, then their hardware moat would have been even more difficult to cross. But if the Maya 100 Trainium, Inferentia, or TPU chips can do what these customers want at cheaper prices, just as the AWS CEO gave the example of customers saving 60 to 70% on their inference bills, and if this trend continues, then I think Nvidia could be forced to lower prices. As a matter of fact, staying on the subject of inference, when Microsoft execs were looking to reduce dependency on Nvidia, they found Grok chips to excel at inference, and they pointed to those chips as another big cost saving opportunity both for themselves and for their customers. Grok recently announced that their 14 nanometer silicon could do an impressive 544 tokens per second, which, from what I've seen, is significantly faster than what NVIDIA's state of the art chips can do. Unlike the hyperscalers, Meta doesn't need to acquire GPUs to support external customers' AI workloads. The gigantic amount of spending that Zuckerberg has directed towards acquiring NVIDIA GPUs has gone entirely to support Meta's own AI aspirations, propelling the open source Llama model to the point where it is ostensibly very close in performance with the latest Gemini, ChatGPT, and Claude models. However, similar to the Maya 100 chip, they also recently announced a chip which will in time make them less reliant on the chip colossus. Meta's training and inference accelerator, called MTIA, is designed to handle both the training and inference stages of AI model development. It will come as a surprise to nobody that the MTIA chips are fully integrated with PyTorch, a language created by Meta. On their website, they say that using PyTorch with MTIA is as easy as using PyTorch for CPUs or GPUs. The MTIA software stack benefits from the flourishing PyTorch developer ecosystem and tooling. One takeaway I got from doing this research is that it's probably a good idea to learn PyTorch if you want to get into the field of GPU programming. The first MTIA was released last year, and Meta showed results comparing it to NVIDIA GPUs. It handled low and medium complexity tasks better, but fell behind on high complexity tasks. This measurement was done on a performance to watt basis, so basically measuring the power efficiency. In April this year, Meta released version 2 of the MTIA chip, which had, according to them, 3 times the performance of its predecessor. This accelerator did much better at those high complexity tasks and did well with the recommendation models that are integral to its advertising business model. Meta is still a huge customer of Nvidia, as are the hyperscalers. But from doing this research, I don't think that Nvidia's moat is as big and as durable as many people believe it to be, and I think it will lessen over time. Therefore, to conclude, Nvidia's rise from a humble Denny's diner to being at the forefront of the AI revolution is nothing short of remarkable. Not only have they pioneered gaming and crypto mining, but many of the most significant breakthroughs in deep learning have come as a result of their incredible innovations. As companies, and especially the Mag 7 giants, compete with one another for dominance, spending on the level of nation states, Nvidia will accrue obscene levels of profits. There was a recent report that the US government are considering lifting export restrictions to Saudi Arabia for Nvidia chips. I think there will be a handful of countries, as well as supranational organizations like the EU, who are able to spend the tens of billions required to build the infrastructure needed in the race towards artificial superintelligence, or AGI, however you define that. The sums may actually go into the hundreds of billions for a model. At least that's what Larry Ellison said in Oracle's last earnings call, noting that the price of entry will be about $100 billion and that you'll want ideally nuclear reactors in close proximity to these ginormous data centers filled with AI accelerators to power the models. The deciding factor here will be the rate of innovation. If Nvidia's competitors, and here I'm referring to Alphabet, Amazon, Microsoft, and Meta, as well as to a lesser extent AMD and Intel, and startups like Grok, are able to continuously innovate on the hardware and software layer, eroding the lock in of both Cuda and the extensive hardware ecosystem that Nvidia has built over decades, then I think their operating margins will fall from the 75.1% of the last quarter to a still high but more reasonable number, and their roughly 90% market share of AI accelerators will also decline to a less monopolistic figure. While geopolitical and regulatory factors play a role, the real battle is technological. Nvidia's moat is deep and well fortified, but even the strongest fortifications can be worn down over time. Rivals are building their own bridges, custom silicon, optimized software ecosystems, and innovative AI solutions, making Nvidia's position less unassailable than it once appeared. They may not be 30 days from going out of business, but Nvidia will need to stay sharp if it wants to maintain its lead. I wanted to do this video because I've been holding Nvidia stock since May of 2019, and with the run up in the stock, I wanted to understand the business at a much more granular level. Nonetheless, this video is not investment advice. Because of this video's length, I may actually put this info on a Substack as well. I hope you all enjoyed the video and learned something as well. As always, if you could like and subscribe, that would be greatly appreciated. Thanks a lot. Bye.